Hi ladies and gentlemen, this is Miss Skokin. Prime factorization is a way that we can write a number as the product of its prime factors. What that means is, and you may remember factor trees from Algebra 1, where we take a number like 12 and we split it up into its factors, such as 3 and 4. So 3 times 4 gives us 12. 3 is prime, so we circle it. 4 is not prime. It's what we call a composite number. So we know that we can break 4 down further into 2 times 2. 2 is prime. So we're done now. We have all prime factors. We can rewrite the number 12 as 2 squared times 3. I know that that little bit of a refresher probably was all you needed until we get to the questions with variables starting with G. So what I'd like you to do now is pause the video and work on the questions B through F. And when you're ready to turn the video back on and check your answers, do that, and then we'll proceed on to questions G, H, and I. So I'll see you back in a minute. Since we've had a few of these problems to work on, you probably had your memory refreshed with the work that you did in pre-algebra and algebra 1 with factor trees. Now I just want to remind you, we were able to use the information that we learned when we factored 12 to factor 24, because 24 is 2 times 12. So we could also take that information forward. We know 24 times 2 is 48. And so we can use the prime factorization for 24, multiply that by 2, so that we are able to get 2 to the 4th times 3. If you have a question about this, ask in class. And we're going to take a look now at what we do when we have variables. Our prime factorization for 12, we know, is 2 squared times 3. And in this case, we're just multiplying that by the x squared. So this is the prime factorization for 12x squared. As we move on to question H, we can use what we had for the prime factorization of 24 in the work that we did up above. So we know that this is going to be 2 cubed times 3, just like in question B. And that's going to be multiplied by x squared and y cubed. We've got the prime factorization. That was pretty quick and easy. Now the next one is going to be a teeny tiny bit more work. Let's take a look. We've got x squared times y cubed times 48x times y to the 5th. So we're going to use the prime factorization on question C for 48. That's going to give us 2 to the 4th times 3. And then we're going to count up the x's. We have x to the power 2, and we have another x. Remember, when there's no exponent, we know that that means it's a power of 1. So that's going to give us times x to the power 2 plus 1, which of course is 3. We're going to do the same thing with the y's. So we have an exponent of 3 for the y, and then we have another exponent for the y on the right of 5. Using our exponent rules that we learned, that's going to give us y to the 3 plus 5 power. So we're going to rewrite our final answer for this one. We're going to have 2 to the 4th times 3 times x cubed times y to the 8th. And that's our final answer for that question. Any questions that you have about any of these, please bring them to class so we can talk them over. Let's take a look at the next topic, rational exponents. The word rational has the root in it ratio, and a ratio is when you can write a number in the form p over q, where both p and q are integers. It's a really fancy way of saying fraction. And we can write or rewrite radical expressions using rational exponents. A very smart sounding sentence, but when you see how easy it is, you're really going to understand the pattern. So let's take a look at what we've got in this expression right here. We see the radical symbol, this thing, I know you often call it a square root symbol, but it's actually called a radical symbol. That radical symbol has two different numbers. One of the numbers is underneath the radical, and that number is called the radicand. Then, and that's the number that you're taking the root of. Now, there's another number that is called the index, and the index is the root that you're taking. What does that mean? You could be taking a square root, and that means that you have an index of 2. You could be taking a cube root, and that means you have an index of 3. You could be taking the fourth root, and that means you have an index of 4, and so on. Now, what we've seen up to now is generally where we only have the radical symbol with no index shown. When there's no index, that means you're taking a square root or a root of 2. Over on the right here, notice that we have an index of a and a radicand of n. And so what this means is we can rewrite it using a rational or fraction exponent, taking the radicand, n, and showing that number being raised to the 1 over a power. When we have the square root of n and we see no index, that means that the index is 2. Okay, so I'm taking the number n and I'm raising it to the 1 over a, or 1 over 2, or 1/2 power. So we can either write the square root of n, or we can rewrite it as n to the 1/2 power. The question right below this one, we're taking the square root of n squared, means we can rewrite this as n squared raised, just like it was above, to the 1/2 power. Now we see something that we can use our exponent rule, where we're raising a power to a power, so we multiply our exponents. And we have n squared raised to the 1/2 power. That means we're going to have a base of n, and we're going to multiply the exponent. So 2 over 1 times 1 over 2. We know 2 times 1 is 2. 1 times 2 is 2. We're going to end up with n to the 2 over 2, which means 1, n to the first power. So this is going to be a result of n. So the square root of n squared gives us n. We might have already known this, but this is another way that you can show it and you can prove it using our exponent rules. Now I'd like you to do the next two, the cube root of n and the cube root of n squared, and then turn the video back on when you're ready to check your answers. If you got stuck on these, not a problem, no big deal. Just remember to pay attention to the pattern, and all we're doing is showing something in a different way. So we're not actually doing any arithmetic or anything like that. We're literally just changing the form of the number. The next one, where we have the fourth root of n, is going to be rewritten as n raised to the 1/4 power. And where we have right below that, we have n to the 4, the cube root of n to the 4th. I just want to show you what that's going to look like. We're going to have n to the 4th raised to the 1/3 power. That's going to give us n to the 4/3 power. Now we know 4/3 is an improper fraction. So again, using our exponent rules, we can say that's the same as n raised to the 3/3 power, which is 1, times n raised to the 1/3 power. Because we're using the exponent rule, if we have two numbers with the same base, n, we can add their exponents, 3/3 plus 1/3, which gives us 4/3. So we're using that rule backwards for our own convenience. Now we know n to the 3 over 3 power is the same thing as n to the first power, which is just n, and we know n to the 1/3 power can be rewritten as the cube root of n. So our final answer, we're going to be back in the form that uses the radical symbol, and this can be rewritten as n times the cube root of n, and that's going to be our final answer for that question. I know that this is a new way of looking at radical expressions, but I don't want you to worry too much about it. This again is just for exposure so that you can see what this looks like. You are going to be using these extensively in Algebra 2, but at least you've gotten your first look at them. You do need to know how to change forms, how to go back and forth between the two with the equivalent value. And that is your review for prime factorization and rational exponents.